Hello students, in this video I would like to talk about a very interesting application of the geometric sequence. Now before we go there, let me remind you what we have done in the last lecture very quickly. I gave you the definition of a sequence and few remarks about the sequence. We learn if the general term of the sequence is given, we can calculate any term of the sequence that we want. We realize that there are many different type of sequences exist in the real world, and we wanted to focus our attention on one very particular sequence that has various application in the real world. We call it the geometric sequence. Geometric sequence is a sequence generated using two numbers. Remember, a and r. A is called the first term, r is called the common ratio. Now remember, if these two numbers are known, then you can say some important thing about your geometric sequence. Number one, you can calculate the general term of the geometric sequence using a and r. Recall the formula. An is really a times r to the power n. Alright. We can also calculate sum of first n terms of the geometric sequence using a and r. We don't have to do the summation manually. Remember the formula, s sub n represents sum of first n terms, and it is given by a times r to the n minus 1 divided by r minus 1. We are going to use this formula to deduce one more interesting formula today. Alright, so the application of the geometric sequence that you are going to see today, it is related to that particular summation formula. Alright, so let's begin this video by understanding the definition of annuity. Annuity is the application that we would like to discuss today. So let's start with the formal definition of annuity. Annuity is an amount resulting from the sequence of equal number of payments made at the equal period of time. Alright, so annuity is a number that you obtain by adding equal number of payments made at the equal period of time. If you sum all this account, the resulting number is called annuity. There are many different types of annuity exist in the real world. Alright, we are going to focus our attention on one very special type of annuity. We call it ordinary annuity. So let's try to define ordinary annuity. Let's understand what do we mean by ordinary annuity. If the payment is made at the end of the time period and frequency of the payment and frequency of compounding interest remains same throughout the period, then you call the annuity ordinary annuity. Alright, so we are really focusing on a very simple case, simplest possible case for annuity. Alright, things that remains constant is frequency of payment, compounding interest, and time period. These are the three things that remains constant. Alright, if this is the case, then we would like to call annuity an ordinary annuity. Alright, I would like to give you a couple of very trivial remarks about ordinary annuity. Remark number one, the time between two payment, it's called payment period. Alright, so any time interval between two consecutive payment, I'm gonna call it payment period. And the total time starting from the beginning till the end, I'm going to call it the term of the annuity. Alright, okay, so these are two basic definitions that you need to know, and two remarks about the name of the period. Alright, okay, I would like to show you the formula of annuity. Okay, as I said, the formula for annuity is related to the summation formula for geometric sequence. So we are going to start with summation formula of the geometric sequence. S sub n is a times r to the n minus 1 over r minus 1. Right? What I want you to do here is use the following variables in place of S, A and R. Sorry, S sub n, A and R. Okay, we are going to use the following notations for S sub n, A and R. For S sub n, I want you to use capital S. And again, capital S stands for the sum, or we are going to call it annuity or total annuity if you want. Substitute A equal to R, replace A by capital R. All right, this is our payment, all right, that constant payment, and then replace R by 1 plus I. You can imagine what I would be. I would be the rate of interest, and N is the time. Okay, if you make all these changes in the formula, then above formula takes the following form: S equal to R times 1 plus I to the n minus 1 divided by 1 plus I minus 1. Want you to notice the cancellation of plus 1 and minus 1 in the denominator. And I can reduce that formula to the following form: R times S equal to R times 1 plus I to the power n minus 1 divided by I. Okay, so if you are asked to calculate annuity, then you need to use this formula. Now think about it carefully. How many unknowns do I have here? All right, the total unknown that I have in this formula, let's count it: S, R, I and N. There are four unknowns. There are only four unknowns that are associated in this formula. Out of these four, you will be given three values and you will be asked to calculate the fourth one. Okay, think about it, how many different type of examples one can construct. I can give you interest rate, term of annuity, and then constant payment, periodic payment, and I can ask you to calculate the annuity. These are the standard type of example, right? I supply you basic information and I ask you that give me the amount that person is going to get at the end of that particular period, or compute the annuity. I can also ask this question that I can give you annuity, interest rate and term, and I can ask you that what will be the payment, constant payment that person needs to pay. So suppose somebody wanted to buy a house in next 7 years and he know the price that he would like to pay for the house, and he would like to at least you know make arrangement of 20% down payment of certain figure, let's say 300,000, right? 20% down payment would be 60K. That person would like to know that if he wanted to get 60K in his bank account at the end of 6th year, then what type of periodic payment he would like to make if interest rate is given and time is given. All right, so these are another practical type of question one can produce. I give you annuity, I give you rate of interest and term, and then you can ask the question that what will be the frequency of the period, or what are the periodic payment that person needs to make. We can also create examples that are little trickier, right? I give you annuity, I give you periodic payment, I give you term, and I ask you, tell me what interest rate was charged. All right, or we can create this type of example: I give you annuity, rate of interest, and constant periodic payment, and I ask you that can you tell me how many years the person would need to wait, right? Okay, but again, those two tricky type of question, they are really not in our radar for now. Okay, what's in our radar is these two things: annuity and periodic payment. All right, so I'm going to show you these two different type of examples now. Let's start with the first one. Okay, so again, S is the total annuity, R is periodic payment, I is interest rate, and then N stands for number of periodic payment made. Okay, this is again the same thing that I said, I just repeated. Here is the first example. Compute the amount of ordinary annuity for the given information. This is one simple way to ask the question, right? Periodic payment is $500, rate of interest is 10%, and period is 10 years. Okay, so we can easily construct a word problem, right? Suppose somebody wants to buy something and he's making constant periodic payment of $500 for 10 years with interest rate 10%. What amount will he get at the end of the 10th year? Okay, all right, so here is the solution. I'm going to use that formula, S equal to R times 1 plus I to the n minus 1 divided by I. Okay, as you see, R, I and N are given. I'm gonna plug their values in here, and then I will compute total annuity. 500, 1 plus 0.1 to the 10 minus 1 over 0.1. I really get 500 times 1.1 to the 10 minus 1 over 0.1. Compute 10 power of 1.1 using your calculator. This is the number that I got, 2.594. Need to subtract 1 from it, and then I need to divide it by 0.1. Alright, so looks like we get 500 times 15.94. Multiply those two numbers, you get 7970. This is the amount that the person is going to get at the end of the 10 year. Alright, so this is the total annuity that is going to be that annuity is that's something that the person is going to get at the end of the year. Okay, let's try to see one more example very similar to this. Okay, so compute the amount of ordinary annuity for the given information. R equal to 100, I equal to 0.1, and N equal to 50, right? So suppose somebody make $100 payment, $100 periodic payment for 50 years with interest rate 10%, then at the end of the 50 year, what annuity is, what will be the total annuity? Okay, again we are going to use the same formula, same computation, just numbers are different, right? So 100 times 1 plus 0.1 to the 50 minus 1 over 0.1. If you simplify, you will realize that you will have to calculate 50 power of 1.1. Calculate that power using your calculator. You will realize it's going to be 117.391. Minus 1 divided by 0.1 times 100 is the total annuity. If you simplify further, you will get 116K and $391. Alright, so this is really the first type of problem, super duper simple, right? We can easily create a word problem with this information. Again, the whole idea is just write down what is given and find out, compute the value of the missing variable. Alright, so out of 4 unknowns, 3 unknowns will be provided in the example, right? Okay, let's end this discussion with one final example, which is really a word problem. Alright, and second type of problem. Okay, here is the question. Find the periodic payment which will amount the sum of $21,000 if interest rate is 6% compounded annually at the end of 11 years. Okay, so suppose somebody is planning to buy something after 11 years and he would like to get $21,000 annuity at the end of 11th year. Okay, what is the periodic payment he will have to make? Okay, As I said, it's a practical question, right? Let's try to first write down the information that is given here. Looks like the annuity is given. So S is 21,000. Interest rate I is 6% or 0.06. The term of annuity is 11 years, so N is 11. And then we will have to calculate periodic payment. So we'll have to find out, compute R, right? Here is the formula. S equal to R times 1 plus I to the N minus 1 over I. I'm going to write down this formula in terms of periodic payment. Okay, so solve it for periodic payment. Divide both side, multiply both side by I and divide both side by 1 plus I to the N minus 1. And this is the formula you are going to get. R equal to S times I divided by 1 plus I to the N minus 1. Okay, understand that S, I and N are given. I need to compute R, and that's why I solve it for R first. Okay, throw the values in. 2100 times 0.06 divided by 1 plus 0.06 to the 11 minus 1. Calculate 11 power of 1.06, subtract 1 from it, and then divide that 2100 times 0.06 by that number. You will get the following number, $1,402.65. So if the person is making periodic payment of $1,402.65 every year, then at the end of the 11th year, the total annuity will be 21,000. Alright, so that is perhaps the end of the story for this video. Again, if there are any question, if there is anything that doesn't make sense in this video or in the lecture, feel free to send me an email. I will be more than happy to clear those questions up. Okay. All right.